Hello, good morning to all of you all. Am I audible to all of you all? Is the presentation visible? Okay, good. Okay, thank you. So let's start with today's lecture. Now, in the previous lecture, what we have seen how to show that a given function is harmonic. Given function is harmonic if it satisfies Laplace equation. So if the function is in the Cartesian form, we check whether the given function satisfies the Laplace equation in the Cartesian form. And if the function is in the polar form, then we can check whether it satisfies Laplace equation in the polar form. And in case if it satisfies Laplace equation, then we say that the function is harmonic. Okay, so this is what we have seen. So this was problem type 6 that we had seen. Acha, now in case if the Laplace equation is not satisfied, what does that indicate? Suppose you are checking Laplace equation. Okay, so you are taking, say, the function is in the Cartesian form, function is phi, so you find out phi xx, you find out phi yy, and you add it. And suppose the answer is not 0, everything doesn't get cancelled. So what can you conclude from that? Not harmonic. Very good. Okay. So if it satisfies Laplace equation, then it is harmonic. If it does not satisfy Laplace equation, then it is not harmonic. Okay. So that is very clear. All right. Now we are going to see the last type of problem in this chapter, that is problem type 7. Okay. So for before solving this problem type 7, there are few concepts that we have to see. 1 minute. Oh, this is 1 minute. This is problem type 6, which we have already completed. Yeah. So now let us see the last type of problem in this chapter, that is in this module of complex function. And for that type, as I told you, there are certain concepts that we should know. Now these are concepts which are very simple. So I will be asking you all questions and you all are going to answer me. Okay? So let's see the first one. There are three concepts we are going to discuss. Let's see the first one. If f of z is a complex function, f of z equal to u plus iv, okay, and suppose I tell you that f of z is analytic, what can you say about the function u, which is the real part of f of z? I am telling you f of z is analytic. So what can you say about u? Harmonic. Excellent. Okay. So u is, this implies that the real part, that is u, is a harmonic function in x and y, or it could be r and theta, depends on which form it is given. What can you say about the function v? Harmonic. Okay. So here v is also harmonic. So this is the first concept which we have already seen. If a function f of z is analytic, then it means that the function u, which is the real part, which forms the real part of a function f of z, is harmonic, and the function v, which forms the imaginary part of our complex function, is also harmonic. Okay, so this is concept number 1. Now let's come to concept number 2. Again we have this function f of z equal to u plus iv. Okay. Now suppose if I tell you that this real part u is not harmonic. Okay. If u is not harmonic, what can you say about f of z? if the real part function, that is u, is not harmonic, what can you say about the whole entire complex function f of z? It is not analytic. Very good. Yes. So if u is not harmonic, we don't even know about v, but just u. Agar not harmonic hai, then we can say very confidently that f of z is not analytic. Okay? Alright. So this is the second concept. Let's look at the third concept. Again, we have this function f of z equal to u plus iv. And now suppose if I tell you this imaginary part wala function v is not harmonic. What can you say about f of z now? If v is not harmonic, then again f of z is not analytic. Okay. So these are the three concepts that we are having. If f of z is analytic, then we know that u is harmonic, then we know that v is harmonic. And we have a special name for these two. They are called as harmonic conjugates of each other. Okay. Now here if we have f of z equal to u plus iv, and if we come to know that u is not harmonic, only the real part, we come to know that it is not harmonic, then we know that the function f of z cannot be analytic. Okay, if it were analytic, this has to be compulsorily harmonic, but ये harmonic नहीं है, so then f of z is not analytic. Similarly, if we come to know that the imaginary part, we don't know what the real part is, but the imaginary part is not harmonic, then we know for sure that f of z is not analytic. Okay, ये concept सबको अच्छे से समझ में आया? Okay, so based on this, we have the last type of problem. The last type of problem is you would be given either the real part or the imaginary part of a complex function. मतलब आपको सिर्फ u दिया जाएगा या फिर v दिया जाएगा, where u is the real part of f of z, v is the imaginary part of f of z. And what you need to show is the function f of z is not analytic. You are given, suppose you are given only u. Suppose you are given u. And if you have to show that f of z is not analytic, how will you show that? If you are given real part u, forget about v. Okay, सिर्फ u दिया है आपको, real part u, it is u और v. तो हम पहला केस 1 डिस्कस करते हैं कि अगर u दिया है आपको क्वेश्चन में और आपको शो करना है f of z is not analytic, where f of z is u plus iv. Okay, तो ये कैसे शो करेंगे? U should not be harmonic by checking whether U is harmonic or not. Excellent, excellent. All of you are correct. Okay. अब इसमें मुझे एक डाउट है. To show that f of z is not analytic, we can also show that Cauchy-Riemann equations are not satisfied. अगर Cauchy-Riemann equation satisfy नहीं हो रहा है, तो भी तो function not analytic है ना? So why can't we check whether Cauchy-Riemann equations are satisfied or not? अभी हार्मोनिक के लिए इतना सेकंड ऑर्डर डेरिवेटिव तक फाइंड आउट करना पड़ता है, बिकॉज वी कांट फाइंड v फ्रॉम u. v इज नॉट देयर, वी हैव ओनली u. एक्सेलेंट. ओके, तो अभी यहाँ से आपको देखो एक क्लियर आइडिया मिलेगा कि इफ यू हैव टू शो दैट द फंक्शन इज एनालिटिक, सपोज विच इज द टाइप 1 प्रॉब्लम वी सॉ, यू हैव टू शो दैट द फंक्शन इज एनालिटिक. कॉशी-रीमान इक्वेशंस चेक करना है, और कॉशी-रीमान इक्वेशंस चेक करना है मतलब आपको रियल पार्ट और इमेजिनरी पार्ट दोनों होने चाहिए. दैट इज द ओनली वे. ओके, बट सपोज इफ यू हैव टू शो दैट f of z is not analytic, तो उसके दो तरीके हैं. It depends on what is given to us in the question. अगर आपको क्वेश्चन में f of z का रियल पार्ट u पता है और इमेजिनरी पार्ट v भी पता है, you know v, in that case we'll check for Cauchy-Riemann equations. We show that Cauchy-Riemann equations are not satisfied and we can show it is not analytic. Okay, but अगर आपके पास सिर्फ u है और आपको नॉट एनालिटिक एफ ऑफ जेड इज नॉट एनालिटिक शो करना है, वहां पे Cauchy-Riemann इक्वेशन नहीं चेक कर सकते बिकॉज v इज नॉट देयर. So in that case we show that u is not harmonic and hence f of z is not analytic. Okay, similarly case 2, अगर आपको imaginary part v दिया है क्वेश्चन में, so if v is given to you and you want to show f of z is not analytic, again I mean only v is given to you, so again we can't check Cauchy-Riemann equations because the real part u is not there. Okay, तो सिर्फ एक imaginary part v दिया है, तो to show that f of z is not analytic, अब क्या करेंगे, you will show that v is not harmonic. Okay, I hope you have understood this idea. ये आइडिया समझ में आया है? Okay, now let's go to the problem. Now see the wording of the question. एक तो क्वेश्चन डायरेक्ट पूछ सकते हैं, इफ द रियल पार्ट ऑफ एन एनालिटिक फंक्शन इज दिस देन शो दैट इट इज नॉट एनालिटिक, वो डायरेक्ट हो जाता है. आई हैव गिवन द क्वेश्चन वेयर द वर्डिंग्स आर लिटिल डिफरेंट. ओके, लेट अस रीड द क्वेश्चन. शो दैट there does not exist an analytic function whose real part is 3x square minus 2x square y plus y square. There does not exist an analytic function. मतलब अगर ये जो फंक्शन आपको दिया है, इसको अगर आपने रियल पार्ट इसको u कंसीडर किया, तो इसका जो एनालिटिक इसका जो फंक्शन है f of z, it is not analytic. Does not exist an analytic function means the function is not analytic. Okay, so the wordings are given in a slightly different way. All right, so let's see the solution. तो सबसे पहले रियल पार्ट दिया है तो इसको हम u बुलाएंगे, इमेजिनरी पार्ट दिया होता तो v बुलाते. तो u इक्वल टू 3x स्क्वेर माइनस 2x स्क्वेर y प्लस y स्क्वेर. ओके, तो u दिया है. देन वी से लेट द फंक्शन जिसका ये रियल पार्ट है वो फंक्शन लेट इट बी f ऑफ z. सो f ऑफ z इक्वल टू u प्लस iv, ये अपना फंक्शन है. ओके, अब हमें शो करना है कि देयर डज नॉट एग्जिस्ट एन एनालिटिक फंक्शन, मतलब ये अगर u है तो ये जो फंक्शन f ऑफ z है ये एनालिटिक नहीं हो सकता. तो वो कैसे शो करेंगे, बाय शोइंग दैट दिस फंक्शन u इज नॉट हार्मोनिक. तो नॉट हार्मोनिक मतलब लप्लास इक्वेशन टेस्ट करना पड़ेगा. लप्लास इक्वेशन के लिए वी नीड सेकेंड ऑर्डर डेरिवेटिव ऑफ u विथ रिस्पेक्ट टू x and second order derivative of u with respect to y. Okay, so let's begin the differentiation. So first of all we differentiate u partially with respect to x, तो मिलता है ux इक्वल टू 3 इंटू एक्स स्क्वेयर का डेरिवेटिव है 2x माइनस दिस 2 एज इट इज, एक्स स्क्वेयर का डेरिवेटिव है 2x, y एज इट इज, प्लस डिफरेंशिएशन इज विथ रिस्पेक्ट टू x, यहाँ पर कोई x का टर्म नहीं है इसलिए डेरिवेटिव इज 0. ओके, let us write this properly. So we get ux equal to 3 2s are 6x minus 2 2s are 4xy. तो ये हमें ux मिल गया. We will differentiate this once more with respect to x. So derivative of ux partially with respect to x is uxx equal to 6 as it is. Derivative of x is 1 minus 4 into derivative of x is 1 into y. We'll write it properly. So we get uxx equal to 6 minus 4y. So we got the second order derivative of u with respect to x. Alright. Next we differentiate u with respect to y. So here is our u. We are differentiating it partially with respect to y. तो इसका partial derivative with respect to y will be uy equal to, ये 3x स्क्वेयर है, इसमें कोई y टर्म नहीं है तो इसका डेरिवेटिव 0 हो गया, माइनस 2 इंटू एक्स स्क्वेयर एज इट इज, y का डेरिवेटिव है 1 प्लस y स्क्वेयर का डेरिवेटिव है 2y. ओके, we'll write this properly. So we get uy equal to minus 2x square plus 2y. Next we'll differentiate this once more with respect to y. So we get uyy, that is second order partial derivative of u with respect to y equal to, यहाँ पर कोई y का टर्म नहीं है तो इसका डेरिवेटिव 0 है, प्लस 2 into derivative of y with respect to y is 1. We'll write this properly. We get uyy equal to 2. Okay. So now we got second order partial derivative of u with respect to x, second order partial derivative of u with respect to y. Now we are going to check Laplace equation. So Laplace equation का left hand side ये Cartesian form में है, so that would be uxx plus uyy. Let's substitute. Uxx is 6 minus 4y plus uyy is 2. तो यहाँ पे 6 plus 2 is 8 minus 4y. That's it. इसके आगे और कोई simplification नहीं होता है. So what do we observe? This is not equal to 0. So uxx plus uyy is not equal to 0, means Laplace equation is not satisfied. Laplace equation is not satisfied means u is not harmonic. And if u is not harmonic, that means f of z is not analytic. Okay? तो ये प्रूव कर रहा था ना, there does not exist an analytic function. मतलब ये जो फंक्शन है ये एनालिटिक नहीं हो सकता. So that is what we have shown. F of z is not analytic. Did we understand this? Okay, so this was the last type of problem. Now these are questions which are asked for 5 marks in question number 1, that is compulsory question. Okay, I have taken only one example because it's very clear. I'll be giving more problems for in the practice. Okay, so with this we complete module number 4. Okay, did we understand this entire module? मॉड्यूल नंबर 4 समझ में आया? Okay. How many types of problems are there in module number 4? 7. Very good, very good. Okay. All of you have understood all the 7 types of problems? Yes. Okay. So now, with this we complete this particular module. Okay. Now what we are going to do is, I am going to do a quick revision of all the types of problems that we have seen in this particular module. Okay, क्योंकि सारे थोड़ा similar लगता है, all the types of problems seem a bit similar. So we are going to quickly revise all the 7 types of problems that we have seen in this module, that is complex function. Okay. All right, let's get started. What was the first type of problem we saw? First type of problem जो था, it was where we were given a complex function f of z, or it was given as a function of z या फिर as a function of x and y, और हमें क्या करना था? We had to show that this function f of z is analytic and we had to find out its derivative f dash of z. Okay, ये हमारा first type of problem था. The questions are like this. Prove that f of z equal to, यहाँ पर देखो f of z is given in terms of x and y, is analytic, and find f dash of z in terms of z. So the question can be asked like this, or see, it could be asked like this. Prove that f of z equal to sin z. So here the function is given and it is given in terms of z. So it is analytic and find f dash of z. Okay. अब इसका solution procedure देखते हैं. तो इसमें फर्स्ट स्टेप है, यू हैव टू आइडेंटिफाई u and v, that is the real part and the imaginary part. If the function is given in terms of x and y, you can identify u and v directly from the function, directly from the question. The part which does not contain I is u, the part which is multiplied with I is v. Okay, but अगर function is given in terms of z, तो कैसे identify करेंगे u and v? Z equal to X plus IY. Khushi. Tanisha, Milne rule. No. What is Milne-Thompson's rule used for? Tanisha? What is Milne-Thompson's rule used for? No, no, you need not be sorry. Just give me the answer. Can you repeat the question? Yes. सी ये जो सोल्यूशन प्रोसीजर है, ये दो टाइप ऑफ, मैंने एक्चुअल क्वेश्चंस लिए हैं ताकि हमें समझ में आए कि किस तरह के क्वेश्चंस आते हैं. ये फर्स्ट टाइप में, फर्स्ट टाइप ऑफ प्रॉब्लम क्या है, हमारा एफ ऑफ जेड दिया है एंड वी हैव टू शो दैट इट इज एनालिटिक एंड वी हैव टू फाइंड एफ डैश ऑफ जेड. ठीक है, तो हियर सॉल्यूशन में द फर्स्ट स्टेप इज फाइंड यू एंड वी. Now, if the question is given in terms like f of z is in given terms of x and y, u and v identify करना बहुत easy है, correct? But if the function is given in terms of z, तो उसमें से आप u और v कैसे identify करोगे? I am still speaking about step number 1. Yeah, you put z equal to x plus iy and then you separate the real and imaginary part. Okay, separation of real and imaginary part करना है. So when you separate the real and imaginary part, you get, 1 minute, where did the cursor go? Yeah, you get u and v. So you find, first step is you find u and v. Second step क्या करना है, u का derivative partially with respect to x, u का derivative partially with respect to y. Then v का derivative partially with respect to x, v का derivative partially with respect to y. Okay, ये चार partial derivatives find out करना है. Step number 3, you check whether the Cauchy-Riemann equations are satisfied. मतलब ux and vy same होने चाहिए. uy and vx should be negatives of each other. So we check whether Cauchy-Riemann equations are satisfied. Fourth ये जो है, this is a step which we just write as far as the problems in our syllabus is concerned. Okay, all the four partial derivatives are continuous. तो ये अगर satisfied है, we just write all the four partial derivatives are continuous. Okay, so if it is continuous, if Cauchy-Riemann equations are satisfied, then we know that f of z is analytic. तो वो first part हो गया. The next part where we have to find f dash of z, we use the formula f dash of z equal to ux plus ivx. Jeet has asked, will they always be continuous? As far as in general, no. The answer is they need not be always continuous. Okay, I am just talking about problems in our syllabus. In our syllabus, the problems that we come across, if Cauchy-Riemann equations are satisfied, then these would be continuous. So those are the kind of problems which are included in our syllabus. In general, Jeet, they need not be continuous. Okay, so there was a type of problem where uh, it was discontinuous, the partial derivative was discontinuous, but then वो type of problem जो है वो आपके revised syllabus में से निकाल दिया है. So we do not have that. In fact, it was removed in 2012 का revision में ही वो वाला type of problem निकाल दिया है. Okay, so this is only concerning to the problems of your syllabus. Okay, so now here f dash of z equal to ux plus I vx, ये formula use किया, ux और vx आपने यहाँ step number 2 में find out किया है, इसको substitute करेंगे. तो इसको इसमें अगर आपने substitute कर दिया, you get f dash of z in terms of x and y. How f dash of z equal to ux plus I vx? That is the formula for f dash of z. That is the formula for the derivative. We have not seen the derivation of the formula, we are just remembering the formula. Okay, iska derivation is simple, not that difficult, but then the derivation is not included in your syllabus, so I have not taken this. We have to just take this formula f dash of z equal to ux plus ivx. Okay, all right, then this will give you f dash of z in terms of x and y. To get it in terms of z, we use Milne-Thompson's rule, where we put x equal to z and y equal to 0. Did we understand this? Ankit, is your doubt cleared? ओके, अभी इसमें कुछ पॉइंट्स क्या याद रखना है. मोस्टली हियर द स्टेप्स आई हैव गिवन इज विथ रिस्पेक्ट टू कार्टेशियन फॉर्म. तो इसमें एक और फॉर्म है कॉशी-रीमान इक्वेशंस का, दैट इज पोलर फॉर्म. सो व्हेन डू वी यूज पोलर फॉर्म? We use polar form if the given function is in terms of r and theta, or if the given function is log z. This particular example we have seen. Given function is z raised to n. You can use for any z raised to n, but preferably n greater than or equal to 3 के लिए actually आप solution के procedure में convenience देख सकते हैं. Okay. So in these three cases we will use polar form. That is when the given function itself is in the polar form, or given function is log z, or given function is z raised to n where n is greater than or equal to 3. In these three cases we use polar form. So Cauchy-Riemann equations जो चाहिए वो भी polar form में होगा. It would be ur equal to v theta upon r and u theta upon r equals to minus vr. Okay, so this is the point which you have to remember. So this is about type 1 problem, how we can show that a given function is analytic. Okay. Next, let us go to the second type of problem. Type 2 problem was where you were given an analytic function and you had to find the values of unknown constants like a, b, c, d and so on, p, k, etc. which were present in the function f of z. This was type 2 problem. तो यहाँ function analytic दिया है आपको और आपको ये unknown constants के value find out करने हैं. For example, see some question like this. Determine the constants a, b, c, d if f of z is equal to this function. See here a, b, c, d are present. This is analytic. ये कार्टेशियन फॉर्म में हुआ. या फिर फाइंड p if f of z equal to r square cos 2 theta plus I r square sin p theta. This p is unknown, is analytic. Okay, तो यहाँ पे फंक्शन एनालिटिक बताया है आपको. You have to find the values of the unknown constants. इसका प्रोसीजर देखते हैं. तो इसका प्रोसीजर में फर्स्ट स्टेप इज आइडेंटिफाई द रियल पार्ट एंड द इमेजिनरी पार्ट, दैट इज u and v. दैट कम्स वेरी इजी. जिसमें i प्रेजेंट नहीं है दैट इज u, और जिस जो i के साथ मल्टीप्लाइड है दैट इज आर v. स्टेप नंबर 2 में वी फाइंड आउट पार्शियल डेरिवेटिव ऑफ u विथ रिस्पेक्ट टू x, u विथ रिस्पेक्ट टू y, v विथ रिस्पेक्ट टू x, v विथ रिस्पेक्ट टू y. देन वी यूज Cauchy-Riemann इक्वेशंस वन एट अ टाइम. तो पहला इक्वेशन यूज किया ux इक्वल टू vy, और ये इसमें ux सब्स्टिट्यूट किया, vy सब्स्टिट्यूट किया, and we compare the coefficients of the similar terms on the left hand side and on the right hand side, and then solve to get the value of the unknown constants. मतलब लेफ्ट हैंड साइड में x स्क्वायर टर्म है तो राइट हैंड साइड में भी x स्क्वायर टर्म को ढूंढो और दोनों का कोएफिशिएंट्स को इक्वेट करो. लेफ्ट हैंड साइड में x रेज टू 4 इंटू वाई स्क्वायर है, राइट हैंड साइड में भी x रेज टू 4 इंटू वाई स्क्वायर ढूंढो और उनके कोएफिशिएंट्स compare करो. Okay, so compare the coefficients of the similar terms on both the sides and solve. So next we use the second part of the Cauchy-Riemann equations, uy equal to minus vx. Substitute uy, substitute vx in this. Again compare the coefficients of similar terms on both the sides and solve, and you will get the values of the unknowns. यहाँ पर एक बात हमने देखा था कि if only one unknown is to be found out, then we need not use both Cauchy-Riemann equations. ये step 4 में ही आपको आंसर आ जाएगा. Then you need not proceed ahead. Okay. So this was problem type 2. Next we come to problem type 3. Problem type 3 में you are given the real part, that is u, or the imaginary part, that is v, of a complex function. What you have to do is find the harmonic conjugate. Harmonic conjugate का मतलब क्या है? अगर रियल पार्ट u दिया है तो उसका हार्मोनिक कॉन्जुगेट होगा v, और अगर इमेजिनरी पार्ट v दिया है तो उसका हार्मोनिक कॉन्जुगेट होगा u. ओके, सो वी हैव टू फाइंड द हार्मोनिक कॉन्जुगेट एंड देन वी फाइंड आउट f ऑफ z. अगर u दिया है, हार्मोनिक कॉन्जुगेट v फाइंड आउट किया, तो f ऑफ z इज इक्वल टू u प्लस iv. इसमें u और v दोनों सब्स्टिट्यूट करेंगे एंड वी गेट f ऑफ z. अगर v दिया है, we find its harmonic conjugate u, and then again we substitute that in f of z equal to u plus iv. So this is how we can find out harmonic conjugate and the analytic function. The questions of this type were like this: find the harmonic conjugate of v and find the corresponding analytic function. तो यहाँ पे harmonic conjugate और analytic function दोनों find out करने बोला है आपको. या फिर द क्वेश्चन कैन बी आस्क्ड लाइक दिस, हार्मोनिक कॉन्जुगेट मेंशन नहीं किया है क्वेश्चन में, डायरेक्टली उन्होंने बोला है फाइंड द एनालिटिक फंक्शन whose real part is sin 2x upon cos hyperbolic 2y plus cos 2x. ओके, सिर्फ डायरेक्ट एनालिटिक फंक्शन बोला है और ये रियल पार्ट है, ये u है, तो एनालिटिक फंक्शन तो u प्लस आई वी है. ओके, तो सिर्फ u दिया है तो पहले हम v फाइंड आउट करेंगे और फिर उसका एनालिटिक फंक्शन फाइंड आउट करेंगे. ऑलराइट, ओके, सो लेट्स सी द सॉल्यूशन. तो यहाँ पे गिवन u, I've just narrated this solution for u, गिवन v रहेगा तो भी सिमिलर प्रोसीजर रहेगा. ओके, सो सपोज इफ यू आर गिवन u, then step 2 में you find out इसका partial derivative, that is ux and uy. Then step 3 में we use Cauchy-Riemann equations to find vx and vy from ux and uy. Using this equation, vx क्या होगा minus uy, vy क्या होगा ux. Okay, so we use Cauchy-Riemann equations. Next we use total differential formula for v. तो dv will be equal to vx dx plus vy dy. ये vx इसमें सब्सटीट्यूट करेंगे, vy इसमें सब्सटीट्यूट करेंगे. ओके, सो वी गेट dv. तो फ्रॉम dv हाउ टू गेट v? v विल बी इंटीग्रल ऑफ dv, बट इस dv में dx भी है, dy भी है, सो द इंटीग्रेशन विल बी स्पेशल इंटीग्रेशन. व्हाट इज दैट स्पेशल इंटीग्रेशन? यू इंटीग्रेट ऑल द टर्म्स इन vx dx, इसमें जो है सब इसमें इंटीग्रेट करना है, प्लस एक बार इंटीग्रेशन विथ रिस्पेक्ट टू x हो गया, when you reach this particular term we don't want any x, so you integrate terms in vy not containing x with respect to y. Perform these two integration, you get v. Okay, so that is your harmonic conjugate. Then for the next part, that is the analytic function, f of z is u plus iv, substitute u, substitute v, जो आंसर मिलेगा that would be in terms of x and y. To get it in terms of z, we use Milne-Thomson's rule, that is put x equal to z and y equal to 0. So this is a third type of problem. Okay, to find harmonic conjugate and the corresponding analytic function. या फिर question होगा just find analytic function. Let's come to problem type 4. Problem type 4 में क्या दिया होगा? You will be given a family of curves. That is, you will be given the equation of family of curves. फैमिली ऑफ कर्व्स है, कैसे पता चलेगा? आपके इक्वेशन में आर्बिट्ररी कांस्टेंट है, देन इट रिप्रेजेंट्स फैमिली ऑफ कर्व्स. व्हाट यू नीड टू डू इज फाइंड इट्स ऑर्थोगोनल ट्रेजेक्टरी. ओके, सो क्वेश्चन देखो ऐसे रहेगा, फाइंड ऑर्थोगोनल ट्रेजेक्टरीज ऑफ द फैमिली ऑफ कर्व्स. दिस कर्व हियर, इफ यू सी वन आर्बिट्ररी कांस्टेंट इज गिवन, सो दैट मींस दिस रिप्रेजेंट्स फैमिली ऑफ कर्व्स. So let's see the solution procedure. First, write the given equation with only the arbitrary constant on the right hand side. तो equation को इस तरह से लिखो कि सारे terms left hand side में आ जाए, only the arbitrary constant is on the right hand side. Call the LHS as u. Then you find its partial derivative ux, uy. You use Cauchy-Riemann equations to find vx and vy. That is, vx is minus uy and vy is ux. Substitute this in total differential formula, dv equal to vx dx plus vy dy. Once we get dv, we integrate the dv to get v. But dv में dx भी है, dy भी है, मतलब इंटीग्रेशन के अंदर, सेम इंटीग्रेशन के अंदर dx भी है, dy भी है. तो स्पेशल इंटीग्रेशन, what is that? Integral of all terms in vx with respect to x plus integral of terms in vy not containing x. तो ये आपको v मिल जाएगा, और जो भी आपका v है आपने उसको इक्वल टू सम आर्बिट्ररी कांस्टेंट, यहाँ पर हमने k लिया है, इफ यू इक्वेट इट टू दैट देन यू गेट योर ऑर्थोगोनल ट्रेजेक्टरी. अगर यहाँ पे इक्वल टू k नहीं डाला, इट इज हार्मोनिक कॉन्जुगेट. अगर इक्वल टू k डाला तो वो बन जाता है ऑर्थोगोनल ट्रेजेक्टरी. ओके, सो डिड वी अंडरस्टैंड दिस? यहाँ तक समझ में आ रहा है? दैट वाज प्रॉब्लम टाइप 4. Okay, are we going very fast? Good. Okay, next let's move on to problem type 5. Problem type 5 में क्या था? We are given a combination of u and v, like au plus bv or u plus v or u minus v. We have to find the function f of z जिसका रियल पार्ट u है और इमेजिनरी पार्ट v है, that is f of z equal to u plus iv. Okay, So let us see the procedure. इसका example देखो, find analytic function f of z if u plus v, ऐसे दिया रहेगा. तो first step है, call the given equation as 1. Okay, then differentiate this 1 with respect to x. Differentiate करने के बाद make the substitution, ux equal to phi 1, vx equal to phi 2, x equal to z, y equal to 0. ये जो मिलता है इसको हम इक्वेशन नंबर 2 बोलेंगे. ये सब्स्टिट्यूट करने के बाद जो मिलता है we call it as equation number 2. Okay, next we differentiate 1 with respect to y. Then we use Cauchy-Riemann equation with respect to y. जब differentiate करोगे uy और vy मिलेगा. So we use Cauchy-Riemann equations to get ux and vx. And then we make the substitution, ux equal to phi 1, vx equal to phi 2, x equal to z, y equal to 0. और substitution करने के बाद जो मिलता है we call it as equation 3. फिर ये equation 2 और 3 को हम solve करके we'll find phi 1 and phi 2. This phi 1 and phi 2 will substitute it in the formula f dash of z equal to phi 1 plus I phi 2. So we have got f dash of z here. This f dash of z ko when you integrate, you get f of z. And that is what we had to find. Find the analytic function f of z. Okay. So this was our problem type 5, where we had to find the analytic function when a combination of u and v is given. Please upload type 4 at classroom. Dheeraj, type 4 ka what you are saying, what you want me to upload? You mean जो PDF है वो? Are you talking about the PDF? Okay, I will check. Okay. ठीक है, तो ये type 5 हो गया. Now we come to type 6. Type 6 is when you are given a real function. The function could be called by any name. उसका commonly used name है phi या फिर u या फिर v. So you are given a real function and you have to prove that the function is harmonic. You have to show that the function is harmonic. Example देखो ऐसा रहेगा, show that the function is harmonic. तो इसमें जो फंक्शन दिया है, यहाँ पर v दिया है, तो हम क्या करेंगे, इसका पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू x फाइंड आउट करेंगे, सेकंड ऑर्डर पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू x फाइंड आउट करेंगे, पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू y फाइंड आउट करेंगे, सेकंड ऑर्डर पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू y फाइंड आउट करेंगे. देन वील चेक वेदर इट सैटिस्फाइज लप्लास इक्वेशन. तो यहाँ पर लप्लास इक्वेशन उसने सेटिस्फाई किया तो इट इज हार्मोनिक. अगर लप्लास इक्वेशन सेटिस्फाई नहीं किया, इट इज नॉट हार्मोनिक. Here since the question is show that it is harmonic, तो वो Laplace equation satisfy करेगा. Okay. So this was type 6 problem. Next let us see type 7 problem जो आज हमने अभी किया था. Type 7 problem में what are we given? We will be given either the real part, only real part of f of z, that is u दिया जाएगा, या फिर imaginary part v of f of z दिया जाएगा. Okay, या तो u या तो v दिया जाएगा. And we have to show that the function is not analytic. Okay, ये कैसे करेंगे, ये देखो इस तरह से एग्जाम क्वेश्चन होगा, show that there does not exist an analytic function, मतलब the function is not analytic, whose real part is, तो ये real part है तो उसको हम u बुलाएंगे. अगर यहाँ पे क्वेश्चन में इमेजिनरी पार्ट होता तो हम उसको v बुलाते. ओके, तो यहाँ पर सपोज अगर उसको u बुलाया तो नेक्स्ट स्टेप में उसका पार्शियल डेरिवेटिव्स, डेरिवेटिव ऑफ u विथ रिस्पेक्ट टू x, सेकेंड ऑर्डर पार्शियल डेरिवेटिव ऑफ u विथ रिस्पेक्ट टू x, पार्शियल डेरिवेटिव ऑफ u विथ रिस्पेक्ट टू y, सेकेंड ऑर्डर पार्शियल डेरिवेटिव ऑफ u विथ रिस्पेक्ट टू y, ये फाइंड आउट करना है. इसको लप्लास इक्वेशन में सब्स्टिट्यूट करना है एंड द आंसर विल नॉट बी जीरो. If answer is not 0, that means this function u does not satisfy Laplace equation. That means u is not harmonic and that means f of z is not analytic. Okay, so ये है अपने 7 types of problems. Okay, so type 4 in the classroom that I will check. So this is all about module 4. Okay, I am uploading practice problems also. Do practice them. Okay. Now I will also take a quiz of this. I will inform you when the quiz will be taken. Now most probably the quiz will be taken on next Thursday. I am giving you 1 week ka notice. Today is Wednesday. Next Thursday 2 to 3 के lecture में मॉड्यूल 4 का ट्यूटोरियल आपका लिया जाएगा. सो उसके लिए क्वेश्चंस विल बी फ्रॉम द नोट्स या फिर द प्रैक्टिस प्रॉब्लम्स में से क्वेश्चंस दिए जाएंगे. ओके, सो दिस इज अबाउट मॉड्यूल 4.